Welcome to Easy BTech, your guide for BTech and beyond. In the channel, you can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss about the topic CPLD. Okay, so it is another type of PLDs, Programmable Logic Devices, CPLD. Okay, CPLD. Okay, CPLD is nothing but a complex programmable logic devices. It is complex programmable logic device. Okay, so it can be operate programmably. It can be store the data and process the data. Okay, so it is designed by designed by Paul like blocks. Programmable array logic blocks. Okay, Paul like blocks and or array. So programmable and programmable and or arrays. Programmable and fixed or arrays and macro cells are used. Macro cells. Okay, programmable and arrays and or arrays, macro cells. Okay, so macro cells used. Okay, macro cells used. Okay, now so it is easiest design. It is easy design. It is easy to design. It is easy to design. Okay, it is easy to design. Low power consumption, low power dissipation. Okay, low power dissipation, low cost design, low cost design than FPGA. Okay, it is a so FPGA more logic blocks are there. So comparatively less number of logic blocks. Okay, low cost design, low power dissipation, easy design than FPGA. Okay, and it is a non-volatile memory device. Non-volatile memory device. Non-volatile device. Non-volatile memory. Okay, non-volatile memory. So it is a ROM based design, non-volatile memory device. So when power off, data will not arise. When power off, stored data will not arise. So power off, so data not arise. Data not erase. Not erasable. Okay, it is a not erasable, non-volatile memory stored in this complex programmable logic devices. So used in all digital gates. Used in digital devices. Digital devices. Used in digital devices. Digital devices. We can use in adder, decoder, digital circuits. So adder, decoders. Okay, adder, decoders. So this we can write it as a comparison between. So it is easy to design, complex to design. FPGA. So low power dissipation, high power dissipation in FPGA. Low cost design, high cost design FPGA. Non-volatile memory, that is a volatile memory FPGA. Okay, so it is programmable and or. But whereas FPGA designed by lookup tables. Okay, so this is and or based design, but FPGA used by the lookup tables. So last class we discussed FPGA designed by lookup tables. Okay, multiplexers and stored data. Okay, processed through the macro cells. Okay, so FPGA is designed by lookup tables, but here CPLD is designed by and or arrays. Array types and macro cells are used. Okay, there is no and or in FPGA. Okay, so let us see the structure of CPLD. Let us see the structure of CPLD. Structure of CPLD. It will be asked you in the external examination. So you can write down that what is a CPLD and how it will be designed. Okay, then after you can discuss about this what is structure of the CPLD. Okay, like this is first one IO connections, IO block. We can say it is IO block. You can say it is IO block, which are connected to the Paul like blocks. Okay, Paul like blocks. So we have PLDs. PLDs two types, PLA and PAL. But here used only Paul like block. Okay, Paul, programmable array logic. So from here we are using programmable interconnection. Okay, so it is from here to can use the Paul like blocks. Okay, it is a block, Paul like block, which are connected to the IO block, input output block. Okay, input output block. This is IO block, and below also Paul like blocks. Okay, Paul like blocks, which is interconnecting block. Paul like blocks. You can draw this as it is in examination. Okay, and so on. We can use the interconnections, Paul like blocks. Okay, more number of Paul like blocks are used. Here we use IO connections, IO block. From here to here we can connect. From here to here we can connect. Okay, so from here to the programmable interconnecting. Here also we can take this IO connection. IO blocks are here ma. Okay, from here to here we can connect it. Okay, right, let us see this one. So first one is this is a Paul like block. Okay, Paul like block. Okay, Paul like block. So it is Paul block. Okay, Paul IO block. This is IO block. This is input output block. This is also IO block. Okay, this is a Paul block. Paul like block. Okay, it is a Paul block. Programmable array logic. Paul block. IO connections. IO block. Okay, input output block. It is programmably. Then the data is connected to the Paul like block, and so in the Paul like block and or arrays of and or and is programmable, or is fixed. It is IO block. Okay, so interconnection. Programmable interconnection. It is programmable interconnection. Okay, it is programmable interconnection block. Okay, programmable interconnection block. Programmable interconnection block. So Paul block. Okay, Paul block interconnection block. Okay, and IO blocks. Okay, okay, and inside of the Paul block, AND gates, AND gate is programmable, OR gate is external, and also some macro cells are used. Okay, so input blocks are connected to the, so according to program the data will be connected to the Paul like blocks and interconnecting. After the Paul like blocks are completed, it will be in one block, then it will be completed, then it will go to the next level Paul blocks by using these interconnections. By using the interconnection, it will be connected again to the next level blocks. Okay, Paul blocks. Okay, programmable array logic. So Paul is a programmable array logic. Okay, programmable array logic. Programmable. Okay, programmable array logic. Programmable array logic. Okay, so programmable array logic. So and is programmable, and programmable, and programmable, and programmable, and programmable. R is fixed. R is fixed, which you are studied in Paul structure. Okay, so R is fixed. R is fixed. External OR gate. Okay, so complex design, complex of PLDs. Okay, so it is more blocks are used here. More blocks are used here. Okay, let us see any one structure of let us see any one structure of Paul block. Okay, right. Let us see the any structure of this Paul block. This is a Paul like block. It is a Paul like block. It is a Paul block. Okay, Paul block using the interconnection, programmable interconnections. Okay, programmable interconnections from IO input output. This is another programmable Paul block. Another programmable block. Okay, another programmable block, Paul block. Okay, so which are connected and planes and R planes. Let us take this inputs AA complement, BB complement, CC complement. Okay, so let me take this. So this is a NOT gate, complemented path. The complemented path. So this is also one complemented path. Complemented path. Complemented path. Okay, so from here we can take the gates. Okay, we can take the gates, right. Here also we can take one type of gate, AND gates, AND gate connections, programmable AND gates. Okay, this is one AND gate, this is one AND gate, and AND gate connections. The AND gate connections are connected over here. Okay, AND gate connections. Here also AND gates are taken. Programmably it is designed. Okay, programmable connections. Internally the Paul block is connected programmable, and after that it is OR gate, and which will be given to the XOR gate, and the XOR gate output is connected to the D flip flop. Okay, D flip flop. So from here to, okay, one more multiplexer. Okay, multiplexer is connected over here. Multiplexer is connected over here. Multiplexer output is goes to a buffer. Okay, so from here directly which can connect it to the output IO pad, output connections. Right, from here to here you can also take OR plane. Okay, OR gates connected to OR gates. From OR gate to XOR gate connected. This is one XOR gate design. This is XOR gate. XOR gate output is connected to the D flip-flop. Flip-flop output is connected to again one multiplexer. Again one multiplexer design. So from here to the selection path will be taken selection over here and a buffer storing, and which will be connected to IO connections. Okay. Now, so this is AND gate, programmable AND gate. Okay, OR gate, and this is XOR gate, D flip flop. Okay, D flip flop and multiplexer. So this is multiplexer and buffer. Okay, so this is a buffer circuit, and this one is a output connection. So buffer, from the buffer which may be connected to the IO interconnections, like input, or which may be connected to the directly output. Okay, so this is what Paul block. This is a Paul block. Paul block. So Paul block represents AND programmable, or fixed, XOR, D flip flop. Okay, Paul block. Paul block representation AND is programmable according to the logic function. Then OR is a fixed gate. Okay, and also followed by XOR gate. It is connected to again the D flip flop. Okay, flip flop output, it is connected to the mux. Okay, multiplexer. So it may be OR gate, XOR gate directly which may be connected, or it may be store. So D flip flop is for storage and buffer. Okay, so buffer which will be take as it is the data process. Okay, from multiplexer output to the output pin. Okay, input output block. So each Paul block representation and programmable, so internal designed. So it is a one structure of CPLD. So it is a diagram representation. So diagram representation, so figure representation. So a structure of CPLD Paul block. Okay, PAL block, right? It is a PAL block. So one structure of a Paul block and is programmable from the interconnection. So these are the programmable interconnections. Programmable interconnections. Programmable interconnection. From the programmable interconnection, the input lines are connected. Okay, input lines are connected, and AND planes, OR gates. Okay, OR gates. So OR gate, XOR gate. So when XOR gate is equal to if you are taken logic 0. Okay, it is taken logic 0. So if OR gate output is 0, then XOR gate is 0, then data will no change. Then it will be connected to the D flip flop and multiplexer and buffer, and then it will be connected to the output. Okay, so programmable AND plane in Paul structure. In the Paul structure, so input lines. Okay, programmable input lines. Programmable programmable input lines. Okay, programmable input lines. So programmable input lines we may take up to 16 input. Okay, 16 input, 16 input line, 16 input line. Okay, 16 input, and then AND gates are programmable. AND gates are programmable. AND gates are programmable. Okay, AND gates are programmable. AND gates are programmable. OR is fixed. Okay, OR gate is fixed. OR gate is fixed. OR gate is fixed. Okay, OR gate is fixed. So each OR gate is fixed. Each OR gate, okay, each OR gate takes so 5 to 20 inputs. 5 to 20 inputs. Okay, 5 to 20 inputs. So OR gate output connected to OR gate is connected to the OR gate connected to XOR gate. Okay, XOR gate. So XOR gate one input, XOR gate one input, XOR gate another input. XOR gate another input is XOR gate another input is, so OR gate output is connected to XOR gate. XOR gate another input logic 0. Another is input logic 0. So there is no change the output. So as it is, OR gate will be passed. So OR gate output no change. So OR gate output no change. Okay, OR gate output no change through XOR gate. No change through XOR gate. Okay, XOR gate. So then it is connected to flip flop. Then connected to D flip flop. So D flip flop stores the data. Okay, stores the data. Okay, stores the data. Then okay, then through the multiplexer, then through multiplexer out, then through multiplexer data connected to buffer. Okay, data connected to buffer. So from the buffer the data it will be input or output. So from the buffer the data connected to input as a input or output or output. So this is a process is happened. In this Paul structure. So the programmable interconnections which we may take the inputs from the IO block. Okay, from the IO block. So inputs may be taken. Okay, so inputs are connected to AND gates according to the programmable. All AND gate outputs are connected to the OR gates. Okay, OR gates connected to this XOR gate. So if OR gate is 0, okay, if OR gate is 0, so if OR gate is 0, what happens? XOR gate is 0. Now what happens? XOR gate. So 0 0 output will be 0. Okay. If OR gate is no change, so the 0 will be passing through XOR gate will no change. And if OR gate output is 1, okay, if OR gate output is 1, logic XOR another input is 0. So output will be again 1. So no change by using this XOR gate. Okay. So OR gate output 0, then another XOR gate input is 0. So then no change data from OR gate to XOR gate. It is connected to the D flip flop. D flip flop storage the data and multiplexer selection. Then buffer is again connected to the input output from multiplexer to selection of this stored data, or it is a directly data. Then buffer is connected to output or the input connections. Okay, so this may be happened in complex programmable logic devices. So it is a complex than the PAL or PLDs. It is complex than the PAL and PLA. Okay, it is complex than it is. So CPLD is complex than PLD design. So complex than PLD design. Okay, PLD design. Okay, more logic blocks are used. More logic blocks. Okay, more logic blocks. Okay, more logic blocks used. More logic blocks are used. So each logic block Paul like block. Each logic block is a Paul like block. Okay, Paul like block. Okay, Paul like block. So and is programmable, R is fixed, and macro cells are used. So it is a programmable and or arrays macro cells are used. So programmable and or arrays of macro cells are used. So OR gate is each design 4 OR gates are used. Okay, 4 OR gates are used. 4 OR gates like 16 macro cells. Okay, 16 macro cells, 16 inputs. Okay, 16 inputs, right? We can say each 32 each block. So each block, this is each block 4 OR gates. Each OR gate is 5 to 20 inputs. 5 to 20 inputs. Okay, 5 to 20 inputs. So 32 AND gates. Okay, 32 AND gates are used. Okay, this is about the design of CPLD. It may be asked you in the external examination. You can write down of the complex programmable logic devices, and you can draw this block, Paul-like blocks, interconnections, input-output blocks, and you can draw the structure of this one. Each Paul block, AND gate, OR gate, XOR gate, D flip-flop, and multiplexer, buffer, and it will be taken the inputs and AND gates, OR gates, followed by XOR gates and D flip-flop. Okay, CPL is a complex than the PLDs. So more logic blocks are used. Each logic block like a Paul-like block. So it is in digital applications it is used. Digital applications it is used. Used in digital applications. Used in, okay, digital applications. Okay, digital applications. Right, this is about the CPLD. Thank you. Please subscribe our channel, like and inform to your friends. Thank you.